Okay, just to make sure that you have your notes on, make sure you know how to write line segments and lines, rays and planes. So remember, a line, you need your two letters and the line symbol across the top. Line segment, just a line segment on top. Ray, it starts at the end point and then goes on to whatever letter you want. The ray goes a single direction. Plane was 3 letters. And then you also want all your postlets down in your notes. So make sure if you didn't take any notes on 1, 2, that you go back and write notes on them because we use them throughout the year. So our new notes are 1-3, measuring segments. When we're talking about segments, we look at a number line, and our first postulate says every point on a line can be paired with a real number. So we've been using number lines since you were little. Nothing's changed. So 3, 4, 5, 6, 7, 8. So if we go -1, -2, -3, -4, -5, we could put numbers all the way across. To find the distance, and as you notice I put a star here, this postulate I think you already know. So I don't see a reason to write it down. But your distance between 2 points, you will need to write that down because it's something new. It is going to be your absolute value. That's why there's the 2 vertical lines and your 2 points subtracted. Again, absolute value is your distance from 0. So if it's a negative number, it's going to be positive because distance is always positive. When you drive to Homer, you drive 72 miles. On the way back from Homer, you don't say you drove negative 72 miles because you were coming back. It's always a positive number. So if we look at our number line, the distance from 3 to 8, I subtract 3 minus 8, which is -5. Absolute value is +5. -5 minus the -1 is -5 plus 1, or -4. Absolute value is +4. Yes, you can count. 1, 2, 3, 4, 5. 1, 2, 3, 4. But if your numbers are really large numbers, you're going to want to know the distance by just subtracting them and taking the absolute value. Our next postulate is our segment addition postulate. You don't need to write this one down twice. You can just go segment addition postulate. And what it says, if 3 points A, B, C are collinear, again collinear in the same line, and B is between A and C, then AB plus BC is equal to AC. We can take our segments and add them together. So if we look over here and we have our B is between A and C, if I know my value of AB, I can add it to BC and I get the whole length of AC. So if you notice when I wrote this, I didn't put a line segment above it. That means I'm talking about the measures of the segments. So congruent segments, congruent has the tilde and an equal sign, segments with the same length. Equal segments with an equal sign, segments with the same measure. So if we're talking about having the same measure, we use no line segment atop. This would mean the measure of segment RS is a length of 3, ST has a length of 3. So line segment RS would be congruent to line segment ST. The physical line segments are the same length. So we go back and forth with our symbols of whether it is an actual measure or if it's the physical segment's length. So if I look at RS and ST, and if they say RS equals 9 and ST equals 15, so this length is 9, this length is 15, the measure of RT is 24. So they are wanting the physical length of it in measure rather than saying that this segment gives you this whole segment RT. Okay, so another thing in your notes, besides your congruent postulate, your congruent segments, is midpoint. We talk about midpoints a lot. Midpoint is a point that divides a segment into two congruent segments. It differs from segment bisector because a segment bisector is a point, ray, or line or other segment that intersects a segment at its midpoint. So the segment bisector is in the middle of the segment and divides it into two congruent segments because it uses the term midpoint. So a lot of our terms use other terms. So if T is the midpoint of PQ, even if it doesn't look like it in this drawing, this line segment PT would be congruent to line segment TQ. And we mark it in our drawing with just a line. Sorry, I guess that looks more like a line segment, doesn't it? So then if they give us information about PT and TQ, PT is equal to 5x plus 3. TQ equals 7x minus 9. Find PT. So, even though we know both parts, it doesn't help us unless we go back to the midpoint. The midpoint divides it into two equal segments. So knowing that these segments are equal, we put them equal to each other and we have an algebraic equation. They don't want us to forget algebra throughout the year, so they're constantly going back and putting it in. To solve, I always move my smaller of my variables, so I'd move the 5x, and I had a positive, so I subtracted. I always do the opposite. And that gives me 3 on the left side equals 7 minus 5 is 2x minus the 9. So now I come back and I need to move the 9, so I add 9 to both sides. Now I simplify both sides. 12 equals, and this 9's canceled, so I just have 2x. So 2x meant 2 times x, because there's no symbol in between, so you divide both sides by 2, which gives me x equals 6. But I haven't found the length of PT. So now PT is right here. I substitute 6 in for x, so 5 times 6 is 30. Add 3, and I get PT is 33. So, and that's an example of problems you'll have for this homework set. And that's all your notes for section 1-3.